right, today we are diving into a really exciting evolution in artificial intelligence. We're going to go inside the so-called brain of what's called Agentic AI to really understand how these systems are becoming, well, truly autonomous. So, have you ever found yourself wondering how an AI could do more than just, answer your questions? How it could actually start to plan things, take action, and even learn from its own experiences all by itself? Well, that is the core idea right there, and it's exactly what we're breaking down today. Because, look, this isn't just another small, incremental update. We're talking about AI's next big leap. We're really witnessing a fundamental shift from AI being a simple tool to becoming more like a genuine, proactive teammate. Okay, so here's the main difference, boiled down. Traditional AI is pretty reactive. It just kind of sits there and waits for you to tell it what to do. You ask a question, it gives you a response. Agentic AI, on the other hand, is proactive. You give it a high-level goal, and it goes off, creates a plan, and then actually starts doing things to achieve it. It really thinks and acts with a purpose. So how in the world does it actually do all this? Well, the engine that drives this whole thing is a continuous cycle, and it's known as the reason, act, reflect loop. So the loop kicks off with reasoning. This is where the agent takes your goal and breaks it down into a concrete, step-by-step plan. Next, it's going to act. It'll use tools like web browsers or different APIs to actually execute that plan. And then, here's the really crucial part. It's going to reflect. It looks back at the results, analyzes what worked, what didn't, and it uses that new knowledge to get better. It's this constant process of learning and improving. Theory is great and all, but what does this actually look like in the real world? Let's put an agent into action with a pretty practical example. Okay, so imagine you give an AI this goal. It's simple to say, but pretty complex to actually pull off. Plan a one-week trip to Japan for under $1,500. Now, a traditional AI might just spit out a list of travel articles or some general suggestions. But an agentic AI, well, it actually gets to work. So instead of just giving you a bunch of ideas, the agent starts taking real actions. It's searching for flights in real time, it's comparing hotel prices, and it's calculating the total budget as it goes. And get this, if it finds that the best flights are going to blow the budget, it doesn't just give up. It adjusts the plan on the fly, maybe looking at different dates or nearby airports. And after all that, it delivers a complete, ready-to-book itinerary. I mean, that is a massive difference in capability. So, what's making all of this possible? What are the building blocks? Let's take a quick peek inside the agent's brain and see what's going on under the hood. You can really boil it down to 4 key pillars here. First up is memory, which lets it remember the context of your conversation and what it's learned from one task to the next. Then there's tool use, which is its ability to connect to the outside world. Accessing a flight booking API, for example. Third is that reflection piece, that self-correction mechanism we just talked about. And finally, and this is super cool, you can have multi-agent collaboration, where different specialized AIs can team up to solve an even bigger problem. So when you step back and look at the big picture, you realize this represents a fundamental shift in how we should be thinking about AI. We are moving way beyond simple automation and into the era of true autonomy. And let's be really clear about what autonomy means in this context. It's not just about following orders faster. It's the ability to think, plan, and act independently to achieve a goal. It's all about giving the system the what and then empowering it to figure out the how. And this shift is so profound because it changes our role from being a micromanager of a tool to being a collaborator with a problem-solving partner. Seriously, whether we're talking about coding assistants that can find and fix their own bugs, or research bots that can actually discover new information, this is the future of intelligent systems. A future where they aren't just executing our tasks, but are solving complex problems right alongside us. And that leaves us with a pretty fascinating question to think about, doesn't it? Now that you've seen what's becoming possible, what's the very first task you would give to your new AI teammate? It's a pretty exciting future to consider.